Alright, this video is for worksheet 2-6 for the class Hands-on Fun with rational numbers. If you're in this class, I'm about ready to put up the answer key. If you're not and you would like to take this class live to learn about fractions, decimals, and integers, in the description you will find a link to the live class. Alright, so I'm going to put up the answers real quick. Alright, so you see the answers up there. I put the reduced form of the answer and the regular form of the answer because depending on what class you are in, which section of the class that I'm teaching, I kind of wait until I feel like the students are ready to learn reducing to kind of spring reducing on them. That way I have time to see what their multiplication skills are like, their strategies to multiplication, so I can kind of teach it in a way that they'll understand there's many different ways to reduce, and I try to come up with the best solution for that student. So if I haven't done reducing with you, okay, the non-reduced is on here as well. So go ahead and grade your paper, hit pause so that you can grade it correctly and everything, and we will get started with how I got these answers. Okay, so I'm going to assume that if you're grading, you've hit pause, and I am going to start explaining how I got these answers. Okay, so the first thing I have to do when I'm multiplying fractions is I got to turn them into improper fractions. So we did this in class. If you need a video on how to do it, another refresher video, make sure you ask me and I'll send you one. But what we have to do is there are two bags of something, and in each one of these bags are two of something. So let's say they're cookies. So there's two bags of cookies. In each bag of cookie there are two cookies. We got to open up these bags, dump them out to make them improper. That means multiplying how many cookies are in each bag by the amount of bags. So 2 times 2, which is 4. Then I have to add the one leftover cookie that didn't make it into a bag. And my first improper fraction is 5/2. Now, if you are just multiplying straight across, this will be 5 times 3, which is 15, and 2 times 5, which is 10, and then you would reduce. Or if you reduce before math, which means you cancel out these 5s, you would get all the way to the correct answer, which is 3/2. Okay? Or if I made that mixed, 1 1/2, which I know I've already taught how to make it mixed. All right, if not, in your reducing, this is also a proper answer, 15/10. See, it's one of the choices. I could divide both top and bottom by 5. Obviously, 5 goes in it. You can either do that through factor tree or through divisibility rules. Like I said, I kind of decide which way to take a group by what the majority seems to be doing. All right, 5 goes into 15 3 times and into 10 2 times. So you can see I'll still get that 3/2. All right, so the next one, got to turn it improper. That means multiplying these and adding the 3. So 7 plus that is going to be 10/7. All right, now that I've showed both ways, I'm just going to kind of go back and forth. So if I don't show your way and you're really stuck on how to do it, of reducing, you can always contact me and I can help you with that. But you should be okay. If you can't see what you did wrong, then yes, contact me and I'll show you one. But remember, if you haven't done reducing yet, it's okay to not have the reduced answer. So 10 times 14 is 140/35. I give that as an answer, but usually I have already taught you how to turn something into a mixed number, all right, by this point. So I would really like it if you gave me the mixed number. That means asking yourself, how many times can 35 go into 140? And that is 4 times. Or you could have reduced first, which says 5 goes into that how many times, 5 goes into that how many times. You would have had to do that a few times to get the 4/1. All right, for this one, 8 times 1 is 8, plus 1 more is 9/8. Okay, I got to put that 3/1 and this one will be 6, 7 over 2. If I was doing cross canceling, it wouldn't work on this one, only because there's nothing I can cross cancel. So if I multiply across the top, I'm going to get 189, 21 times the 9, 189. And then on the bottom, I'm going to get a 16. Okay? All right, I'm going to turn this into mixed first. 16 goes, how many times can 16 go into 189? Well, I know it can go in once. Drop my 2. 29, once again, 13. This is the numerator. This is the denominator. So the answer becomes 11 and 13/16, and I can't reduce. If I couldn't cross anything out during this step, then I know it's not going to be reducible. But I can turn it into a mixed number. Okay, so first thing I need to do is put that 20 over 1. Now I am going to do the cross-canceling method because it works on this one. Alright, 4 can go into 4 one time, 4 can go into 25 times. So I'm just looking for their common divisibilities or their common factors, okay, depending on how you learn to do it. 5 times 3 is 15, 1 times 1 is 1. That will reduce down to just 15. Anything over 1 is the other number because of our identity rule that says no matter what you divide it by, it's that. Okay? All right, same thing here. 5 over 6 times 24 over 1. The 6 can go into itself once and into the 24 4 times. Again, I'm going to get 20 over 1, which is 20. All right, I'm going to do this one just by reducing aftermath. Okay, so 10 times 3 is 30 plus 2 more is 32 over 10. Next one is 9 over 2 because 2 times 4 is 8 plus 1 more is 9. All right, so I'm just going to multiply straight across. So 32 times 9 is going to be 288. 2 times 20, 2 times 10 is 20. All right, so this is the first thing, though you should be able to turn this into a mixed number. So let's see what that looks like. Drop my 8, drop down my next 8. 20 can go into 88 4 times because that's 80 with a remainder of 8. So it'd be 14, remainder is on the top, that's left over, didn't go into a bag, and it's always out of 20. Now, I would take this answer. But if we've learned how to reduce, then you need to reduce this by its common factor, and that is a 4. 4 goes into 8 2 times and into 25 times. Alright, so there are different ways we can do this, and depending on what the majority of the class seems to be doing well with, I can do it one of two ways. Okay, so either we do it turning these into improper fractions and adding, or we do it the 2 by 2 way. So 7, 10, and 13, I'm going to do the vertical method. All the rest, I'm going to do the improper method, and we'll see what these answers are. And the reason I'm doing, or let me say that again. I'm sorry, I forgot one. I'm doing 7, 10, 13, and 12 the improper way, okay, or the vertical way. 8, 11, 14, 9, and 15 will be done improper method. So if you do it a different method, you didn't get the same answer as me, you can't see what you did wrong, email me, I'll do it the other way. But I'm doing a mix because different kids come into this class having started learning it a certain way, and I like to continue in the way students learn things. So I'm not going to try so hard to change your way, but these are the two main methods of adding fractions. There are a couple of other, there's a crisscross squeeze method that I am very much against, and there is a modified lattice method that I'm very much against. If you came in knowing these, I told you I will not teach that, and I've probably explained why I will not teach that, okay? So these I'm going to do vertically. So I'm just going to do 7, 10, 13, and 12 first. And then I'll go back and do the others. All right. So in the vertical method, we line up our whole number and our fractions. We do this kind of like you do place value in decimals, right? These are my decimals, the decimal parts. These are my whole number parts of my decimal number. So when we do it this method, we're kind of doing it like decimals. All right, so the first thing I do is I add up my my whole numbers and get a 7. And then I add my fractions. Well, 2 plus 4 is 6 over 10. So the answer is 7 and 6/10. And I can reduce that by saying 2 can go into both. And I would get 7 and 3/5. All right, let's do number 10. All right, number 10 is a subtraction, but I can do the same thing. The only problem when you subtract doing the vertical method is there are going to be times when you're going to have to borrow. We're not there yet. I saved borrowing till a little bit down. I made sure none of these would turn into a problem when borrowing was applied. All right, 3 subtract from the 7. I'm going to do my fraction first. Does not matter which one you do first. 3 subtract from the 7 is 4 over 12. 1 subtract from the 3 is 2. Probably best you start with your fraction because of borrowing in the future, but it doesn't really matter. All right, 4 can go into both, so if I'm reducing, I need to reduce it by 4s, which is going to give me 1/3. I could have reduced it by 2s twice. That is also acceptable. Alrighty, let's do number 13. And in number 13, I need to line these up. I'm adding, okay. Oh my goodness, my answer is wrong for 13. So if you did not get the same answer as me, that's because you, it isn't that my answer is wrong. My answer is incomplete. It's 18 and a fraction. I just forgot to finish it. So I forgot to write the fraction beside the whole number. So if you notice that, good for you. All right. So this is the reason why it is probably better if you do your fraction first. If I do my fraction, I see I get 6 over 4, right? Well, that is a whole number. So if I turn this into a whole number, it's 2 and 2/4, or it's 1 and 2/4, sorry. Okay, because the 4 goes into 6 one time with a remainder of 2. Well, what I need to do is, like I would do with decimals, I need to carry that 1 to the ones place. Okay, if I do that, I get 18 over here. So it's 18 and 2/4. Now I can reduce this 2/4 by reducing by 2's. And that becomes 18 and 1/2. So if I get a whole number in this category, I have to do what I do with decimals, and I have to carry it to the next place value. Only fractions can go in that place value. All right, and the last one we're going to do this way is number 12. I'm going to do it down here. So 2 and 3/4 minus 1 and 1/4. Let's do our fractions first. 1 from 3 is 2 over 4. 1 from 2 is 1. So my answer comes out to 1 and 2/4. Well, I can reduce that by saying that they're both divisible by 2, which is going to give me 1 and 1/2. Or I could say 2 is half of 4, so it has to be a half. Anything where the top is half of the bottom is a equivalent fraction to 1/2. All right, so those are the problems that I'm going to do using the vertical method. Now the rest I'm going to do doing the improper fraction method. So if you do the other one, you may want to stop. If you do the vertical method, you might want to stop here. If you do the improper method, you may want to start listening here. Okay? So to make this an improper fraction, I have to multiply and then add. Okay? Just like I did with the multiplication above. If I want to make it improper. So 5 times 3 is 15, plus 3 more is 18. 5 times 5 is 25 plus 4 is 29. Now, with this method, you don't have to deal with borrowing and carrying place values, okay? That is the good point of this one, but you have to work with some pretty big numbers with this one, okay? So if I add across my tops, I got like denominators, so the 5 just comes over, but if I add across my tops, I'm going to get 47. So the first thing I need to do is divide these to figure out how many whole parts I have, and you're going to find out it's 9. Okay, so I know that I have 9 whole parts. The 2 is my new numerator, and the 5, it's still out of 5, so 2/5 is my remainder, my fractional remainder. So the answer would be 9 2/5. All right, I have to take 7 times 3, which is 21, add the 2, which is 23. I don't have to do anything to the next one. So when I subtract these, I get a 22 over 7. Well, I got to turn this into mixed. 7 can go into 22 3 times. That's 21 with 1 left over. So my whole number is 7. This is, it's 3. I have 3 whole parts right here. 1 is my remainder, and it's over 7 because it takes 7 to move it to the next place value, which is a whole. All right, number 11. So I have to, this is where it's going to really get big. All right, so 18 times 1 is 18. 18 plus 6 is going to be 24 over that 18. 18 times 9 is going to be, let's do some math in my head, 162 plus 8 more 170. All right, so if I add these two, I'm going to get 194 over 18. So now I need to make this a mixed number. So let's go ahead and divide these. See how many whole things I can make. And 18 goes into 19 one time, and it does not go into 14, but I have to complete the place value. So I have to put a 0 above that 4 because the 1 is in the tens place. So I have to, the lowest number I can have is a 10. All right, so 10 is my whole number. My leftover part is 14 out of 18, and I can reduce that because they both can take a 2 down to 10 and 7/9. 2 more problems. All right, so 7 times 9 is 63, plus 5 is 68 over 9. 9 times 3 is 27, plus 2 more is 29. And this time I am subtracting. Is that the only, no, we did this one, that's subtraction. So this is the second subtraction. This all got mixed up. All right, so the 9, it goes along. 2 from 68 is 66. Got to divide those. Okay, so let's do some math. 7 times 9 is 63, so it could be 7. Okay, but hold on a minute. Something is not quite right with my math. 6 times 7 is 63, plus 5 is 68. Here's where it is. 27, 28, and 29. I guess it slipped more than I thought when it slipped the answer, when it messed up. Okay, so let's subtract these numbers now. 29 from 68. I'm going to go ahead and do it over here because I'm going to have a little bit of borrowing I'm going to have to do. And you should have gotten 39. All right, 39. Okay, so 4 times 9 is 36. So that's probably the highest I can go. That gives me a leftover 3. excuse me. So I have a whole number of 4, a leftover 3 over 9, and I could reduce that because 3 can go into both, and that would give me an answer of 1/3. Okay, 4 and 1/3. All right, to be able to add these in the improper method, to turn a 9 into improper, you just throw a 1 under it, and that's for any whole number. All right, so 50 times 3 is 150, plus the 7 is 157 over 50. I do not have like denominators, okay? So I'm going to show you a different way to do this type. And this is, I remember that was the plan here, because then there's even amounts for everything and then one that's like this. These people make them extremely hard and they're not. Okay, think of it this way. I have 9 cookies and someone gives me 3 more cookies and one that they had bitten out of, and only 7 out of 50 bites are left in that cookie. Well, then you have 9 cookies plus 3 more cookies, which is 12 cookies, and then you have that part of a cookie that is 7 bites out of 50 left. Okay, don't overthink it. Just add your whole numbers and bring along your fraction. And as you can see, I get the answer of 12 and 7/50ths. Okay, so that's this worksheet, which is worksheet 2-6. Work on it until you feel comfortable with it, and I'll see you in class.